Okay, let's go ahead and take a look at the next problem we have here. It's asking us to find the currents I1, I2, and the power for both of these sources. So taking a look at this problem here, we've got a couple things we can identify. The first being the sources and then the resistances. And if we notice, they all share a common node here. So looking at this, this would lead me to go ahead and drop a node here, and we're going to go ahead and do a nodal analysis on it. So here, I'll call this point V1, so I'll say V of 1. I know I have 3 amps coming in from the left from the source. I'll call this one I1 since it's going in. Then I2 is going that way. They already defined I1 and I2 for us there and there. So if we go ahead and write these, it'll be I2 will be equal to I1 plus the 3 amps. So going from here, if we go and write our equation, do I1 plus 3 amps minus I2 will be equal to 0. And if we go and replace I with V over R, then we will get 0 for I1. We'll get 0 minus 20 volts since we're going from 0 hopping up to V1 with 20 volts. So we know that V1 is equal to 20 volts. Okay. We're not going over any resistance, right? So that method actually won't work. Okay. So I wrote this out so you can see that this isn't always going to work exactly how you want it to, because we're crossing over some resistance value. Now you could do the superposition. However, it's not necessary here. Since we know that V1 here is equal to 20 volts, and we know down here V of G is equal to 0, we know that we're going to lose 20 volts across those two resistors. So we can just say I of 2 is going to be equal to V1 over R equivalent, which in this case will be 20 volts over 15 plus 10 ohms, which will give us 0.8 amps for I of 2. Okay. Now we know I of 2. Now we just need to find I of 1. So if we go and use our equation, I of 1 will be equal to I of 2 minus 3 amps. And when we go and plug this in, we'll get 0.8 minus 3 amps. I of 1 will actually be negative 2.2 amps. So what does that mean for us? Well, that means that the way that they described I of 1 in the beginning was wrong. I of 1 actually goes that way. So it travels through the battery from positive to negative terminals. So what does that mean? That means that this current is so much stronger here that it's pushing it that way. So we know I1, we know I2. We can come over here and say power of the battery is equal to VI. And since we are the current and we are going to hit the 20 volts from the positive terminal with 0.8 amps, I'm sorry, 2.2 amps, this will give us positive 44 watts for the battery, which is absorbing. And if we jump over to the current source, we'll say VI. And since the branches are in parallel with each other, branch here, are in parallel, we can say 20 volts. And then now the 3 amps headed that way. So negative terminal times the 3 amps. This will give us negative 60 watts for the current source, which we'll be supplying. All right, so just a couple different ways to look at this problem and go about it.